I want to show you is that first, before I go to show you this, I want you to see this. I want you guys to know that your syllabus is going to be is the 2023 to 2025 one. So you guys are right in the middle of it. 2024. This is for those who are in 2024. Okay, so from 2023 all the way to 2025, exams that are in that season. So anyway, let's go and see the things that we want to see. I want to first go to page 9 and see the topic that we're going to be doing today. Now, if you remember, we are going to write 4 papers, right? So either it's going to be, we know that P1 and P3, that's for those who are working for the certificate. P1 and P3 are compulsory, right? P1 and P3, no choice. So pure mathematics, these two guys, we are going to have to write them. Then either we'll write paper 4 and paper 5, or we would write paper 5 and paper 6. So we have to write 4 papers, right? So yes, we know that. So right now we're looking at P1 and P3, which are the ones that are coming. For our focus in this video is going to be P3. In the video after this guy, paper 3. And we are looking at, if you see, it has 9 topics. Paper 3 is one of the 4. Remember, we said either you're going to do paper 1, paper 2. Paper 2 is out. Paper 1, paper 3, paper 4, and paper 5. Or paper 1, paper 3, paper 5, and paper 6. So whatever you're doing, paper 3 is right in the middle. You're going to have to do it. It's paper 1 and paper 3 are the 2 biggest ones, okay? You can look at the video where I talk about those things. So now, we are doing this topic, number 4, okay? Which, if I tell you right now, it's one of the smallest, okay? It's one of the smallest of all these 9. Topic number 4 out of these 9. So we only have 9 to cover in here, and then 8 to cover in what? Then we'll do the other, then it'll be the other, paper 4 and paper 5, or paper 5 and paper 6, whatever. So now, let's go to differentiation. We're going to go to should be page 21. It's page 26. Paper 3, pure mathematics 3. And we are doing the differentiation. I want you to see how small it is. Look at how small it is. Sorry for this guy. Look at how small it is. It is very, very small. So I want us to count the number of things together that you have to know in this topic, okay? And we have to find 6 things. We have to find the 6 things that you guys have to know. So let's go through the 6 things in this. Remember, it's chapter 4 out of 9 in paper 3, okay? So that's why it's called 3-4. Paper 3, chapter 4. Now, here's the first thing. It says, use the derivatives of e to the x, ln x, sine x, cos x, tan x, and tan inverse of x. Okay? And they say, together with constant multiples, sums, differences, blah, blah, blah. So, we know that we have the types of functions that we have are Lipet for you guys, the ones which you need to know. Lipet, right? The types. Remember, a function is just something which we use in the calculator to find answers, right? To calculate, like ln of x. It's a function. So you put in x, and it is going to give you an output which you can call f of x, right? So I put in, and it will do ln of that x, right? The one which you have put. So if I put in 2 as my x, what is my function going to do? It is going to say ln 2, right? This is a logarithmic function. It will do something to 2. ln is the function. It is going to do something to your 2, and it will give you an answer. If you put 2 in the function called ln x, then you're going to get an answer 0.6931. So obviously, this guy has done something to 2 because we've given him 2 in this. So these are the functions, right? L is for logarithmic. I keep showing you this, I keep showing you this because it's important. L is for logarithmic, which we have ln x, log base 3 of x, anything, right? If we write lg or log, it will be log base 10 of x. These are all functions. And then I is for inverse trig, okay? inverse trig function. This is another type of a machine. It does something to numbers, this thing. Okay, and it changes and it gives you an answer. So inverse trig are sine inverse of x, sine to the power of -1 of x, or cos to the power -1 of x, or tan to the power -1 of x. Okay, and then we have polynomials. Polynomials are basic, guys. Okay, like x to the 7, it'll be like a variable to a certain power or a number. That's another polynomial. So, or 3x or 7x minus 2, that's a polynomial. These are polynomial functions, right? 7x minus 2, 3x plus 5, x to the power 7, blah, blah, blah. These are polynomial, basic stuff. And then you have exponential. I'm going to put E. E is for exponential, which is x being a power. Like 4 to the power of x. X is now the power. Or e to the power of x. This is the common one, which you guys will meet. It's a type of a polynomial. X, why is it why is it an exponential? Because x is the power. And then for trig, these are the basic guys, which is sine x, tan x, cos x. These are trig functions. They keep going, okay? We have sec x. These are all trig. We have cosec of x. These are all trig functions, okay? And these are the functions which you got to know. So now, if you know this, let's look at the things now and let's talk about the types of differentiation which you now have to know. Okay, we say there are 6. Let's see the 6 types of differentiation. Okay, the differentiation of the different things. Let's see. First one is going to be here. We are interpreting what is in your syllabus, okay? They said derivatives of e to the x. What is this? Exponential function. So you have to know derivatives of exponential functions, okay? Because here x is a power, right? So it's an exponential function. Then derivative of ln x, that's the second thing. So we have to know derivatives of natural logs, okay? Natural logarithms. Derivative of it's logarithmic functions, the L, right? Remember in Lipet, our log. But when the log is ln, it's called a natural log, okay? It is log base e. You can see the topic on logarithms, you understand it more. Then these 3 will be trig, okay? Trig functions, right? Sine, cos, tan, those are the trig functions we're going to do. Then we have tan inverse, which is going to be inverse trig, okay? Which is going to be inverse trig. Now, if we separate it, normally we are going to include inverse trig in trig. So we can say so far we have done 3. 1 is exponential. 2 is the derivatives. You have to know how to differentiate ln. How to find the derivatives. How do I differentiate? You have to know ln x and his friends. Then you have to know derivatives of trig functions and inverse trig. We'll put them together as our 3, trig and inverse trig, right? If you're done with that, is this the end? No. Look at this one. They said together with constant multiple sums, blah, blah. It just means when we say constant multiple means if I now put a 2 in front of ln x, you must be able to still differentiate it. Whatever, if I put any number, or if I make them add one another, ln, I say 2 ln x plus 5 ln 3x, you know what I mean? You must be able to do them. Okay, and composites. Composites is when you have one function inside another, like to say, instead of ln x, if we say ln of 2x plus 5, okay? So we have this guy inside ln. It's now a lot of stuff inside here. It's no longer just an x. So we have to know how to do those. Anyway, we're going to see that. Now look at the number 4. It's products. Products. Then number 5, quotients. So we're going to do product rule. Product rule for differentiation. And quotients would be the quotient rule. That's going to be number 5. Then what is number 6 and number 7? Number 6 would be, look here, find and use derivative of a function which is defined. I'm going to change the crayon. Let's choose red. Which is defined, and they say parametrically. So we are going to have to know this parametric differentiation, and then implicitly we will have to know implicit differentiation. Okay, so we are going to have to know how many. This is number 5, and no, it's number 6, and this is number 7. So how many? 7 stuff. We have to know 7 things, and then we are going to now do this. Look at these questions that they've given us as examples, and also how to apply. Because if you see, they said use in problems to find tangents and normals. So we're going to have to apply them to find tangents and normals. This is what we're going to do. 7 stuff. And if you know those 7, you come back, you look at the syllabus, then you should be good. We should be good. Okay. One more thing which I'm going to do